when the ray of light passes through another medium and
Mhm.
it is bended towards or away from the normal due to the change in speed. That phenomena
Okay.
is called refraction.
Okay. So the bending of light when it passes from one medium to another medium. Okay. This phenomena is called as the refraction of light. So the direction in which the light bends, it depends on the optical densities of the two medium. Okay. So it depends on the optical density of the two medium. If the medium is, let's say, if the light is passing from rarer medium to denser medium. So here in the last class, we had defined these two. Let's say we draw the normal here. So this is our normal. And suppose you have our incident ray. So this is our incident ray. And this incident ray is supposed to travel in a straight line. But due to the presence of another medium, here it is supposed to move in the same straight direction. It is supposed to move in the straight line. And but due to refraction of light, this ray of light, it bends towards the normal here. The bending of light is observed towards the normal. If you have this as medium 1 and medium 2, and it bends towards the normal, so we say that medium 2 is denser. 2 is denser than A. So we also call them as optical density. The optical density of 2 is greater than 1. The optical density of a substance is measured with the help of the refractive index. So in the last class, we had discussed also about the refractive index. So what was the formula for refractive index?
C,
Hmm,
C by V, sir.
C by V. The refractive index is equal to C by V, where we also call this refractive index as the absolute refractive index. Why we call it as the absolute refractive index? If the medium 1 is air, if the medium 1 is air or vacuum, so we call this refractive index as the absolute refractive index. Okay. It can also happen that it's not air, there are two different media, and then also we can measure the refractive index. But in that case, that refractive index will be a relative refractive index. We will see how to measure the relative refractive index also. But currently, we should have our clear idea about the absolute refractive index. So what are the SI units of absolute refractive index or refractive index? Can anyone give me the SI unit of refractive index?
Sir, there is no SI unit.
No units. It does not have any units, not even SI any. So there are no units for refractive index as it is a simple ratio. The refractive index is a simple ratio of the speeds of light between the two media. Okay. So there is, since these two, they are the speeds of light, and if you divide one of the speed with the other, you will get no units. So here the refractive index does not have any units. Okay. So now we will discuss about the laws of refraction. In the last earlier we had discussed about the laws of reflection. Okay. So can anyone give me the laws of reflection? Just to speak of the laws of reflection. Yes, can anyone tell the laws of reflection?
Angle of
Sir,
incidence is equal to angle of reflection.
Okay, and
so
any other?
the incident ray reflected ray normal lie on the same side.
Okay, the incident ray, the reflected ray. So here we do not have the reflected ray, we have the refracted ray. The incident ray, the refracted ray, and the normal. you have the normal, all lie in same plane. So this is our first law of refraction, that the incident ray, the refracted ray, and the normal all lie in the same plane. This we call as the, this one is the
Sir,
first rule for the law of refraction.
sir,
Yes.
how do they lie in same plane, sir? Yeah,
Uh,
like the refractor ray is on the other side.
what I didn't get your question.
Sir, how is refracted ray and incident ray in the same plane?
In the same plane. Okay. So here we are discussing of the plane. Generally, we are living in the three-dimensional world. Okay. So if you are living in the three-dimensional world, every point in the three-dimensional world can be represented with the help of three coordinates. Okay. So if I make your three coordinates, so your three coordinates can be represented something like this. Let's say I have these three coordinates. Okay. So I have these three coordinates. Let this one be the x-axis. Here you have the y-axis, and here we have the z-axis. So every point in our world can be represented with these three coordinates. And here we observe three planes. Okay. What are the three planes? This plane here, you can see everyone on this plane. This plane is our YZ plane. The floor is the XY plane. And this wall is our XZ plane. This is the XZ plane. So you have here three planes. Now, if your angle, if your incident ray is moving in this YZ plane, if you have the movement of the incident ray in the YZ plane like this, so your normal will also be in the YZ plane and the refracted ray will also be in the YZ plane. The refracted ray, it will also be in the YZ plane only. It will not be in the XY plane or it will not be in the XZ plane. It will be in the same plane. That is what it means.
Okay, sir.
Okay. So this is your first rule, that the incident ray, the refracted ray, and the normal all lie in the same plane. Now the second rule. The second rule is very important here, as it's not the same as the angle of incidence is equal to the angle of reflection. Okay, so here there is no reflection, it's refraction. And we can clearly observe that the angle of incidence is not equal to the angle of refraction. Okay, so the rule says that the ratio of, see, the ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay. And is equal to the refractive index. So if you find the ratio of sine of angle of incidence to the sine of angle of refraction, so this is a constant and this is equal to the refractive index of the given pair of the media. So let us try to understand this in this diagram. So in the diagram you have here, this is your angle of incidence. The angle made between the incident ray and the normal is your angle of incidence. The angle made between the refracted ray and the normal. So this is the, your ray is the refracted ray and the angle between them is R. Okay. So this is the angle of refraction. Now, as per the second rule, it says that if you find out the sine of angle of incidence, so sine of I over sine of R is a constant. This is a constant, and this constant is nothing but equal to the refractive index, which we even calculate by C by V method. Okay, so this sine as we know, Sine is a trigonometric function which you will learn in trigonometry. Once you do your trigonometry in mathematics, so over there you will learn about this function sine. So sine is the trigonometric function, and this ratio, sine of angle of incidence to the sine of angle of refraction, will be a constant, and this constant will be equal to the refractive index. Okay. Now this second rule, it has another name. This rule is also called as Snell's law. So it is also called as Snell's law. So if you are asked what is the Snell's law, according to the Snell's law, you can state that the ratio of sine of angle of incidence to the sine of angle of refraction will be a constant. Okay, and this constant is equal to the refractive index of the given pair of media. Okay. So I think this is clear about the laws of refraction.
Sir, can you wait? I'll just stop you.
The second point.
Yes, sir.
Okay. See, if you are getting confused with this word sine, so sine you will be learning in your trigonometry. Once in mathematics you start your trigonometry, so you will learn about the different trigonometric ratios. There are 6 trigonometric ratios, namely sine, cos or cosine. You have tangent or tan or tangent. Then you have cosec or cosecant. You have sec or secant or cotangent or cot. So these are the 6 trigonometric ratios which you will study in your trigonometry. So out of that, we are talking of the trigonometric ratio sine. If I just explain this sine, so sine of any angle. Suppose if I take a right angle triangle here. So what does this mean? If you have a right angled triangle, okay. So as we know that in the right angle triangle, we follow Pythagoras theorem. Okay. So there is some speciality in the right angle triangle that for a given angle, if you take for a given angle, so suppose this is a given angle x. So for this given angle x, this will be the perpendicular, this side will be the base, and this side will be the hypotenuse. So for this given angle, if you find out the ratio of perpendicular and hypotenuse, so that will be equal to sine. If you want to find out sine of angle x, so sine of angle x will be equal to perpendicular over hypotenuse. And in whatever be your right angle triangle, if the value of x is same, so the value of sine x will be the same. It will not depend on the height of the triangle. It will not depend on the base of triangle. It will not depend on the hypotenuse. It just depends on this angle. Okay. So we call this that the sine of the angle of incidence. So for an instance, I can give you example. If suppose this angle is 30 degree, if this x is 30 degree, so we know the value of sine 30 degree would be equal to 1 by 2. So whatever triangle you take, in that triangle, if this angle is 30 degree and you find the ratio between perpendicular and hypotenuse, you will get your answer as 1 by 2. Okay. So that is what is said here. You find the ratio of sine of angle of incidence. You find sine of angle of refraction and divide both of them so that you will get numerically equal to the refractive index of the material. Okay. Understood this? So you may get there, the chances however are very less, but still you can get some questions which are based on these trigonometric functions also. Okay, since in your mathematics they are present, so maybe not now, but once you complete your trigonometry in mathematics, so you can get a question relating to this. However, up to now, whatever questions have been asked, they have just been asked by the definition. Okay, that states Snell's law. So according to the Snell's law, the sine of the angle of incidence to sine of angle of refraction will be a constant, and this will be equal to the refractive index. Okay. Any other doubt to anyone? Okay. So in the last class, we clarified one more thing, that if the object is coming from rarer medium to the denser medium, in which side will the ray of light bend? Yes, in which side will the ray of light bend? Yes. And all your cameras are off. Please turn on your cameras, everyone. Everyone, please turn on your camera. Okay, Shubhansh, any
Yes.
doubts?
No, sir.
No. So we can move further. Now we will observe here the refraction occurring through a glass slab. We will take a rectangular glass slab and we will observe the refraction through a rectangular glass slab.
Sir, I'm writing, sir. Could you once more?
Okay. Okay, this is.
Sir, completed.
Complete.
Completed, sir.
Okay. Proceed. Now we have to do the refraction through a rectangular glass slab. Refraction through a rectangular glass slab. So we will observe what a glass slab is and where the how the refraction occurs through this glass slab. Okay. So what is the refractive index of the glass slab, if anyone remembers? Is there anyone who remembers the refractive index of the glass slab? Glass. The refractive index of the glass was 1.5 or 3 by 2. Okay. So I just want to know that the just that glass slab is denser than air. Okay. So here we have a glass slab, and let us say we have a ray of light which is coming from air into the glass. Okay, there is a ray of light which is coming from air to the glass obliquely. So here we get a ray of light that's entering this glass slab at this point of incidence. So at the point of incidence, I can draw a normal. So normal means the perpendicular to this. This is our this is the normal at the point of incidence. The expected path of this ray of light. See the ray of light which was coming, this was coming something like this, and the expected path is this. This is the expected path that is to be followed by this ray of light. Okay. This was the expected, that if there is no bending taking place, so the ray of light should pass something like this. Okay. But now we know that the refractive index of glass is higher. So that means there will be a bending of light. The ray of light will bend, but in which direction? In which direction will the ray of light bend? Yes, I can say that air is a rarer medium and glass is a denser medium. So in what direction does the ray of light bend? Does it bend from when it's going from a rarer medium to a denser medium? So in which direction does the ray of light bend? Does it bend towards the normal or does it bend away from the normal?
Towards
Towards the normal. When the ray of light is passing from a rarer medium to a denser medium, the ray of light bends towards the normal. Anyone having any doubt that in which direction it will bend, or getting confused sometimes to find out that in which direction it will bend? No? Okay. So we can see here that the ray of light has bent and it has bent towards the normal. So here you have the angle of incidence. This is our angle of incidence. This is the angle of refraction. So I can observe that there is a small value of the angle of refraction. That means there is a very large refraction occurring. The ray of light has bent towards the normal. So here, this interface or this surface was the interface between air and glass. The ray of light was moving from air to glass. Hence, the ray of light bent towards the normal. Anyone having any doubt? Where will it bend? Aryan,
Yes, sir.
any doubt?
No, sir.
No. But you turn your camera.
Okay, sir. 1 minute, sir.
I should not see everyone to turn on camera.
Oh,
Shubhansh,
sir,
Dharya.
in 1 minute, sir.
Okay. Now at this point, when the ray of light reaches the second surface, so let's mark the surfaces also as A, B, C and D. Now when the ray of light passes to the second surface, it reaches the second surface. So at this point of incidence, again we will draw the normal. So at this point of incidence, again we draw the normal here. Let's say, let us have this normal at the point of incidence. So we have the normal at this point. Okay, this is the normal. Now see, the ray of light is now moving. It's now moving from glass to air. That is, now it's moving from a denser medium to a rarer medium. So in which direction should the ray of light bend? Yes. In which direction should the ray of light bend? See, this was going something like this.
away from normal.
Yeah. So it should be bending now away from the normal. See, this was going like this. It was supposed to go like this. Outside this, it was supposed to go something like this. But now the ray of light will bend away from the normal. So it will bend a little bit away from the normal and its bending will be like this. So it will bend something like this. You will observe here the refracted final emergent ray. So if I mark all the ray of lights, this is the ray of light which is entering. We call this as the incident ray. This one is our incident ray. This one is our refracted ray inside the glass slab. This is our refracted ray. And this one is the emergent ray. Okay. That means the ray of light which is coming out. So you have the emergent ray, the refracted ray, and the incident ray. Finally, you have this angle of emergence, which we call E. This is our E, which is the angle of emergence. Okay. So there is a specific characteristics about this. If you observe the incident ray, see, I have marked the incident ray over here, and these dotted lines, they represent the direction in which it was expected to move. Okay. So this is the direction in which the incident ray was supposed to move, and this is finally the emergent ray in which it is actually moving. So the ray of light is actually moving like this, but it was supposed to come from here. Okay. So in this case, we observe that the incident ray and the emergent ray are parallel to each other. This is a very important observation from here, that the incident ray in this glass slab, we observe that incident ray and emergent ray are parallel to each other. So you can do this activity at your home if you have a rectangular glass slab and suppose if you have a laser light. So if you have a laser light and a rectangular glass slab, so you can do this activity, or you can do it even with the help of a pin. So with the help of pin, I will show you how to do it. So the first thing, that the incident ray and emergent ray are parallel to each other, and also you will find the angle of incidence. You will find here the angle of incidence is equal to the angle of emergence. Okay. So both these angles are equal, and that is why you will observe that the incident ray is parallel to the emergent ray. Okay. So this is so because the glass slab is rectangular in shape. Had the glass slab been not been rectangular, so the incident ray and the emergent ray would not have become parallel to each other. The incident ray and emergent ray, they are parallel to each other. This is because the glass slab is rectangular in shape, and the lateral displacement between them, we observe that there is a lateral displacement between the incident ray and the emergent ray. The lateral displacement will be indicated by this distance d. So this distance between them, we represent this with the symbol d. The symbol d is the distance between, or the perpendicular distance between, the incident ray and the emergent ray. Okay. The perpendicular distance between the incident ray and the emergent ray is called as the lateral displacement. Okay. So what will be the lateral displacement? Let's write down lateral displacement. Lateral displacement means the emergent ray, or you can say the distance between, you can say the perpendicular distance Are you people making a note of it? Have you drawn the diagram? Have you drawn the diagram? Please
Which
draw the diagram. The diagram is very important. You should have your hands on the diagram. The perpendicular distance between the incident ray and the refracted and the emergent ray is called lateral displacement. You will find very little about this in your NCERT. Just in a box, you will see something about the lateral displacement. Okay. You will also study about this lateral displacement in your practical. If you are doing a practical, so you will observe this activity, that yes, there is a lateral displacement. That is, the emergent ray and the incident ray, they are parallel to each other with some distance between them. And this lateral displacement, it depends on lateral displacement, it depends on the thickness of glass slab. It depends on thickness of glass slab, and it depends on thickness of glass slab and refractive index of the glass slab. So these are the two factors on which the lateral displacement depends. Okay. Any doubts here from refraction through glass slab? So first thing, while drawing this ray diagram, you should keep in mind that when the ray of light passes from a rarer medium to denser medium, that is, when we observe the first refraction occurring, we observe here that first refraction occurs at the surface AB. At the surface AB, when the incident ray enters from air to glass. So when the incident ray enters from air to glass, there is a refraction that occurs. So giving you the refracted ray. Now when the refracted ray reaches the opposite surface CD, so here you have the second refraction occurring. There is a refraction occurring a second time. Okay. So here you have the second refraction occurring, and we observe here that again now the ray of light is moving from a denser medium to a rarer medium, and hence the bending of the light, it takes place away from the normal. The ray of light, it bends away from the normal. Right? So we observe here the bending of light occurring away from the normal. So hence, but however, the bending is the same. The amount of bending that occurs over here is the same that occurs over here. Okay. You can observe this effect by using pins. If you use, let us say if you use two pins over here, if you plot two pins over here and try to observe the two pins from the opposite side, if you observe from the opposite side, if you start observing from here, so the two pins, they will not appear to you somewhere here. They will not appear to you here, but you will be able to see those pins in this line, not in this line. Okay. So with the glass slab, we will be able to find out the lateral displacement of a glass slab. Any doubts in this refraction? Okay. So we'll continue with this refraction. In the refraction, we have the next refraction through spherical lenses. So that is our next topic, refraction through spherical lenses. So till then, anyone having any doubt? Okay, one more thing. We have here a relative refractive index. So let's add that also. Relative refractive index. Up to now, we just talked of the absolute refractive index, that is the refractive index when we have the first medium as air. Now we have the relative refractive index. So relative refractive index, it is the refractive index of medium 1 of medium 2 with respect to medium 1 when ray of light travel from one to 2. When the ray of light travel from medium 1 to medium 2. Okay. So how we obtain it? It is obtained as the ratio of speed of light in medium 1 to the medium 2. So that means everything is the same. The only thing is that we do not have here medium 1 as compulsorily air. The medium 1 is not necessarily air. It can be any rarer medium or denser medium. Okay, so you have here two media. Let's say you have the medium 1. Here you put your medium 1 and here we put your medium 2. So we give here the refractive index of medium 2 with respect to 1. Okay, so we'll discuss about this in the next class. Bye everyone. Good night and see you.
Bye,
Thank you,
sir.
sir. Bye, sir.
Okay.
Thank you, sir.
Bye, sir.
Bye,
Bye.
sir.